Anatolia is a land where history runs deeper than the ruins of ancient cities. Long before the rise of the Ottoman Empire, before the arrival of the Turks, and even before the mighty Romans or Greeks, this land was home to civilizations whose genetic legacy still lives within the people of modern Turkey. But how much of their DNA remains? And how did the first settlers of Anatolia shape the genetic identity of Turks today? The journey begins over 15,000 years ago, when the first known inhabitants of Anatolia, hunter-gatherers, roamed the land. Unlike their European counterparts, these early Anatolians carried a unique genetic signature that did not fully match the Western hunter-gatherers of Europe or the early farmers of the Near East. Instead, they belonged to a distinct lineage known as Basal Eurasians, one of the most ancient genetic groups ever identified. Their DNA links modern Turks not only to the origins of civilization, but also to a lost chapter of human history that predates even the great empires of Mesopotamia. But the most significant transformation began around 7,500 BCE, when Anatolia became one of the first places on Earth where humans abandoned their nomadic ways and embraced agriculture. At sites like Çatalhöyük, one of the earliest known cities, people began domesticating plants and animals, setting the stage for the rise of civilization. These Neolithic farmers weren't just shaping Anatolia, they were shaping the entire world. Recent genetic studies confirm that they carried their DNA into Europe, becoming the ancestors of the first European farmers. This means that modern Turks still carry a high percentage of these early Anatolian farmer genes, proving that, despite all the later invasions, migrations, and cultural changes, the genetic foundation of Anatolia remained intact. But there's another layer to this story, one hidden in maternal DNA. Mitochondrial DNA, which is passed exclusively from mother to child, reveals a direct and unbroken genetic line from these early Anatolian farmers to modern Turks. This means that many Turkish women today share the exact same maternal ancestry as the women who walked the streets of Çatalhöyük nearly 9,000 years ago. Despite wars, conquests, and political shifts, their lineage survived. However, Anatolia's genetic journey didn't end there. These Neolithic communities paved the way for the great civilizations of the Bronze Age, bringing waves of new migrations, technologies, and languages. Soon, a new group of people, Indo-Europeans, would arrive, introducing one of history's greatest cultural and genetic shifts. They were called the Hittites, and they would reshape Anatolia's genetic identity forever. Anatolia was no stranger to change, but around 2000 BCE, something happened that would forever alter its genetic landscape. A new group of people arrived, tall, light-skinned warriors from the vast Eurasian steppe. They were the Hittites, and their arrival marked one of the most significant transformations in Turkish ancestry. But who were they? And how much of their DNA still survives in modern Turks? The Hittites didn't originate in Anatolia. They were part of a larger migration of Indo-European-speaking people who swept across Europe and Asia, bringing new languages, technologies, and, most importantly, genes. Their homeland was somewhere near the Pontic-Caspian steppe, a region stretching from modern Ukraine to Kazakhstan. Genetic studies reveal that these steppe migrants carried a distinct Y-DNA haplogroup, R1b, a marker found in many modern European populations. When they reached Anatolia, they didn't wipe out the existing population, but instead intermixed with the local Neolithic and Bronze Age people, creating a hybrid civilization that would become the powerful Hittite Empire. Unlike the early Anatolian farmers who lived in small, scattered settlements, the Hittites built a vast, centralized kingdom. Their capital, Hattusa, was a city of grand temples, fortifications, and advanced engineering. But their greatest weapon wasn't their military. It was their ability to integrate different cultures. The Hittites ruled over a diverse population that included native Anatolians, Mesopotamians, and steppe migrants. This constant movement of people meant that Anatolia became a genetic crossroads, absorbing influences from the Caucasus, the Aegean, and beyond. Yet, despite their dominance, the genetic imprint of the Hittites wasn't absolute. While their male lineage introduced steppe ancestry, the maternal lines of Anatolia remained largely unchanged. Studies of ancient DNA show that while some Indo-European genes were introduced, the core of Anatolia's population remained genetically similar to its Neolithic ancestors. This means that the Hittites left more of a cultural than a genetic legacy. Their language and traditions would influence later civilizations, but their DNA only became a small fraction of the Turkish gene pool. However, there's one place where their genetic influence is still clearly visible: Central Anatolia. Even today, populations in areas once ruled by the Hittites show higher levels of steppe ancestry compared to coastal regions. This suggests that while the Hittites didn't replace the native Anatolians, their descendants continued to live in the same heartlands where their empire once flourished. But the Hittites weren't the last group to leave their mark on Anatolia. As their empire collapsed around 1200 BCE, a new wave of migrations would begin, bringing in yet another layer of genetic diversity. The next era of Anatolia's history would see the rise of civilizations like the Phrygians, Lydians, and Urartians, each adding their own piece to the genetic puzzle that would one day form the foundation of the Turkish people. Anatolia had always been a land of movement, but as the Bronze Age gave way to the Iron Age, it became a true crossroads of civilizations. With the collapse of the Hittite Empire around 1200 BCE, a power vacuum emerged, and new groups rushed in to fill the void. The Phrygians, Lydians, and Urartians weren't just builders of kingdoms. They were genetic contributors to the evolving population of Anatolia. Each group brought its own influences, languages, and traditions, shaping the ancestry of the people who lived there. But what did they leave behind in modern Turkish DNA? The Phrygians were among the first to take control of central Anatolia. Originally from the Balkans, they crossed into Anatolia and established their kingdom, with Gordion as their capital. They are often linked to the famous King Midas, whose name became legend. But their real legacy lies beneath the surface. Genetically, the Phrygians brought a new wave of European ancestry, introducing haplogroups that connected them to early Balkan populations. Though they assimilated into Anatolian culture, their DNA blended with the locals, reinforcing the genetic diversity of the region. Further west, the Lydians emerged as the rulers of western Anatolia. Unlike the Phrygians, their genetic ties leaned more toward the Aegean and Mediterranean, reflecting a mix of indigenous Anatolian, Greek, and possibly even Near Eastern ancestry. The Lydians were known as the inventors of coinage, a civilization of merchants and traders who interacted with cultures from Egypt to Persia. Their openness to exchange wasn't just economic, it was genetic as well. Over time, intermarriage between Lydians and surrounding populations added another layer to Anatolia's complex genetic history. In the east, the powerful Urartian kingdom rose in the highlands near Lake Van. The Urartians were distinct from both the Phrygians and Lydians, with stronger links to the Caucasus. They spoke a language unrelated to Indo-European or Semitic tongues, and their genetic makeup carried influences from the ancient peoples of Armenia and Iran. DNA evidence shows that populations in modern eastern Turkey, particularly in Van, Erzurum, and Kars, still carry haplogroups that trace back to Urartian ancestry. While their kingdom eventually fell to the expanding Assyrian and Median empires, their genetic imprint remained, passed down through generations of mountain-dwelling communities. What makes this era of Anatolian history so fascinating is the sheer number of civilizations that contributed to its genetic mix. By the time the Iron Age ended, Anatolia had absorbed influences from the Balkans, the Caucasus, the Mediterranean, and Mesopotamia. Each new migration didn't replace the previous population, but instead layered itself onto the existing genetic structure, creating a population that was incredibly diverse. This genetic mosaic set the stage for what was to come. The Greeks, Persians, and later the Romans would all leave their mark, but the foundations of Anatolia's population were already firmly established. And when the Turkic migrations eventually arrived, they would find a land whose people had already been shaped by thousands of years of blending and adaptation. By the time the Iron Age came to an end, Anatolia had already absorbed genetic influences from the Balkans, the Caucasus, Mesopotamia, and the Aegean. But the most dramatic shift was yet to come. In the 11th century CE, waves of Turkic tribes from Central Asia began arriving, bringing a new language, new traditions, and a fresh layer of genetic influence. The question is, did they transform the population of Anatolia, or did they simply merge into an already diverse gene pool? The first major entry of Turkic peoples into Anatolia began after the Battle of Manzikert in 1071, when the Seljuk Turks defeated the Byzantine Empire and established their rule over vast territories. These warriors were descendants of Oghuz Turkic tribes who had traveled thousands of miles from the Altai Mountains and Central Asian steppes. Genetic studies confirmed that they carried a distinct East Eurasian component, with haplogroups Q, N, and C, commonly found among Mongolic and Siberian populations. However, these Central Asian lineages remain a minority in modern Turkish DNA, raising an important question: how much of Anatolia actually became Turkic? The reality is that the arrival of the Turks in Anatolia was more of a cultural transformation than a genetic replacement. Unlike previous migrations, the Turkic presence was defined by military conquest, political dominance, and linguistic assimilation, rather than large-scale population displacement. The vast majority of the local population, who descended from Anatolia's ancient inhabitants, did not vanish. Instead, they gradually adopted the Turkic language, customs, and identity, while their genetic legacy remained largely intact. This explains why modern Turks have much stronger genetic ties to neighboring Greeks, Armenians, and Iranians than to Kazakhs or Uzbeks, despite sharing a linguistic connection with them. However, there were certain regions where Turkic ancestry remained stronger. Nomadic groups such as the Yoriks and Turkmens, who continued their traditional way of life in Anatolia's mountains and plains, preserved a slightly higher percentage of Central Asian genetic markers. Even today, genetic studies show that some rural populations in southern and central Turkey have a slightly elevated presence of East Eurasian haplogroups compared to the urban centers, where centuries of mixing diluted the genetic signal. Interestingly, this period also saw a reverse migration. Many Turks intermarried with locals, while others moved into newly conquered regions like the Balkans and the Middle East. This genetic exchange was not one-sided. Instead, it wove Turkic elements into an already complex Anatolian genetic fabric. By the time of the Ottoman Empire, the Turkic identity was fully established, but the DNA of Anatolia still bore the deep traces of its pre-Turkic past. The people now called Turks were, in reality, the descendants of Hittites, Phrygians, Greeks, Armenians, and countless other ancient groups who had lived on this land for millennia. The Turkic migration was not a genetic replacement. It was the final layer in Anatolia's long, intricate story of cultural and genetic fusion. As the Turkic identity took hold in Anatolia, a new empire began to rise, one that would not only shape the region politically, but also leave a lasting genetic imprint. The Ottoman Empire, 1299 to 1922, was unlike any previous Anatolian power. It wasn't just a state. It was a vast, multi-ethnic empire stretching across 3 continents, absorbing millions of people from the Balkans, the Caucasus, the Middle East, and North Africa. This unparalleled movement of people created a new level of genetic complexity in the land that would later become modern Turkey. One of the most significant contributors to this genetic shift came from the Balkans. As the Ottomans expanded into southeastern Europe, they ruled over Greeks, Albanians, Slavs, and other Balkan populations for centuries. Many of these people were either forcibly relocated or voluntarily migrated into Anatolia, blending into the Turkish population. The Janissary system, which recruited young Christian boys from the Balkans and converted them into elite Ottoman soldiers, was a major factor in this genetic exchange. Over time, this contributed to the introduction of European Y-DNA haplogroups, such as R1A and I2, into the Turkish population, particularly in western and northern Anatolia. Another key genetic influence came from the Caucasus. The 19th century saw large migrations of Circassians, Chechens, and Georgians into the Ottoman Empire, fleeing wars and Russian expansion. Many settled in central and northern Turkey, bringing with them distinct genetic markers, particularly haplogroup G, which is still found at high frequencies among Turkish populations with Caucasian ancestry. Meanwhile, the Ottoman slave trade also played a role in shaping Anatolian genetics. The empire's vast reach meant that enslaved people were brought from North Africa, the Middle East, and even as far as sub-Saharan Africa. Though their numbers were relatively small compared to other groups, DNA studies have found traces of African maternal haplogroups, lineages, in coastal cities like Izmir and Antalya. reflecting the genetic echoes of this era. The genetic impact of the Ottoman period wasn't just about adding new lineages. It also played a role in further blending and homogenizing the population. Unlike earlier empires that ruled over relatively isolated regions, the Ottomans moved people across their vast territories, encouraging intermarriage and cultural integration. This genetic mixture became especially pronounced in major urban centers like Istanbul, Bursa, and Edirne, where people of Balkan, Caucasian, Middle Eastern, and Anatolian descent all lived side by side. By the time the Ottoman Empire collapsed in the early 20th century, Anatolia's genetic diversity had reached unprecedented levels. The population exchanges between Greece and Turkey in 1923 further reshaped the genetic landscape, as hundreds of thousands of Greek-speaking Muslims were resettled in Turkey, while Orthodox Christians of Anatolian descent were sent to Greece. This further blurred the lines between ethnic and genetic identities, reinforcing the idea that modern Turks are not a single homogeneous group, but a reflection of centuries of migration, conquest, and intermixing. The Ottoman period may have ended, but its genetic legacy remains. The people of Turkey today carry the traces of all those who passed through this empire, from Balkan warriors to Circassian refugees, from Arab traders to Anatolian farmers. The Ottoman Empire wasn't just a political entity. It was a genetic melting pot that brought together the diverse strands of history into the DNA of modern Turkey. For centuries, Anatolia had been a land of migration, conquest, and assimilation. But in the modern era, science has unlocked a new way to understand the past, not through written records or historical artifacts, but through DNA itself. Advanced genetic research has revealed startling insights into the ancestry of Turkish people, proving that their heritage is far more intricate than simple historical narratives suggest. The question is, where do modern Turks truly fit in the global genetic map? One of the most revealing aspects of Turkish ancestry comes from Y chromosome DNA, Y-DNA, which is inherited exclusively through the male line. Studies show that the most common Y-DNA haplogroups among Turkish men are J2, R1b, and R1a, each of which tells a different story. J2, found widely across the Mediterranean and the Near East, traces back to Anatolia's earliest farmers, proving that much of the Turkish population has deep local roots. R1b, introduced by Indo-European migrations, connects modern Turks to the Hittites and other ancient steppe peoples. Meanwhile, R1a, which is more common in the Balkans and Central Asia, reflects both Ottoman-era influences and earlier migratory waves. On the maternal side, mitochondrial DNA, mtDNA, inherited exclusively from mothers, tells an even deeper story of continuity. The dominant maternal haplogroups in Turkey include H, U, and K, which are commonly found in Europe and the Middle East. This suggests that while male-driven migrations brought new Y-DNA lineages into Anatolia, the maternal lineage remained largely stable over thousands of years. In other words, despite numerous invasions and conquests, many Turkish people can trace their direct maternal ancestry back to the region's prehistoric inhabitants. But what about autosomal DNA, the genetic material inherited from both parents? Unlike Y-DNA and mtDNA, which trace specific lineages, autosomal DNA provides a broader picture of ancestry. Genome-wide studies show that modern Turks sit at a unique position between Southern Europeans, Middle Easterners, and Caucasus populations. They are genetically closer to Greeks, Armenians, and Georgians than to Central Asian Turkic groups like Kazakhs and Uzbeks. This confirms that while the Turkic migrations introduced a new cultural identity, they did not significantly alter the underlying genetic makeup of Anatolia. Interestingly, Turkish DNA also varies by region. In Western Turkey, populations share more genetic similarities with the Balkans and Aegean, likely due to Ottoman-era movements and historical Greek influences. In Eastern Turkey, genetic ties to the Caucasus and Iran become stronger, reflecting centuries of interaction with Armenians, Kurds, and Persians. Meanwhile, Central Anatolia, often considered the heartland of Turkey, carries a genetic signature that blends these diverse influences while still retaining a strong connection to ancient Anatolian civilizations. Another fascinating discovery comes from traces of Central Asian ancestry in Turkish DNA. While some studies estimate that Turks have between 6 to 15% Central Asian genetic input, this varies significantly between individuals and regions. Higher levels of East Eurasian haplogroups, like Q and C, are found in certain nomadic descended populations, such as the Oryx, but are much less common in urbanized areas where Anatolia's indigenous genetic legacy dominates. Beyond scientific studies, modern genetic projects continue to refine our understanding of Turkish ancestry. Research from the Human Genome Diversity Project and studies by leading geneticists like Hodaglugel and Mali, 2012, and Yunusbayev et al., 2015, confirm that Turkey occupies a genetic middle ground between Europe, the Middle East, and Central Asia. While political narratives often emphasize Turkic origins, the genetic data tells a different story, one of an ancient, diverse, and deeply Anatolian people with only a small but significant influence from their Turkic forebears. DNA has rewritten the history of Turkish ancestry, proving that modern Turks are not a homogeneous group, but a genetic mosaic shaped by thousands of years of migrations, conquests, and cultural exchanges. Every individual carries within them a unique blend of histories, traces of Hittite warriors, Greek philosophers, Persian traders, and Oghuz nomads, all intertwined in the complex genetic story of Turkey. For centuries, myths and political narratives have shaped how people perceive their origins. But when it comes to Turkish ancestry, the truth is far more complex than simple origin stories. Scientific research has uncovered a rich genetic history that challenges nationalist myths and reveals a much deeper, multi-layered heritage. So, what are the most common misconceptions about Turkish genetics? And what does the evidence really say? One of the most persistent myths is that modern Turks are primarily descendants of Central Asian Turkic tribes who migrated to Anatolia. While the Turkic migrations played a role in shaping Turkish identity, genetic studies have repeatedly shown that Central Asian ancestry in modern Turks is only a small fraction, between 6% and 15%. The dominant genetic contribution comes from Anatolia's ancient inhabitants, whose roots stretch back to Neolithic farmers, Bronze Age civilizations, and Iron Age empires. This means that despite adopting a Turkic language and cultural identity, the genetic foundation of the Turkish people remains largely indigenous to the region. Another widely debated topic is the genetic relationship between Turks and other Turkic-speaking peoples. Many assume that because modern Turks speak a Turkic language, they must be closely related to Central Asian populations like Uzbeks, Kazakhs, and Kyrgyz. However, DNA evidence places Turks genetically closer to Greeks, Armenians, and Iranians than to their linguistic cousins in Central Asia. This supports the idea that language shift, rather than large-scale population replacement, defined the Turkification of Anatolia. Some nationalist narratives also exaggerate the genetic differences between Turks and their historical neighbors. For example, political tensions have often led to claims that Turks and Armenians or Turks and Greeks are entirely separate populations with no shared ancestry. Yet, genetic research consistently shows that these groups share significant genetic overlap, a reflection of thousands of years of coexistence, intermarriage, and cultural exchange. Even after the political conflicts of the 20th century, the genetic legacy of this shared past remains embedded in the DNA of modern Turkish people. Another controversial issue is the idea of racial purity, which has been promoted by nationalist ideologies across different periods of history. However, the reality is that no population is genetically pure, and Turkey is no exception. Anatolia has been a bridge between civilizations for thousands of years, absorbing migrations from Europe, the Middle East, the Caucasus, and Central Asia. The diversity seen in Turkish genetics today is not a sign of dilution, but rather a testament to the region's rich and complex past. Even the historical narrative of Turkic identity itself is not as straightforward as many believe. The original Turkic tribes that emerged in Central Asia were themselves a mixture of different ancient populations, including Iranian, Mongolic, and Siberian groups. This means that even before they arrived in Anatolia, the early Turkic peoples were already genetically diverse. The idea of a single, uniform Turkic race is not supported by genetic science. Rather, the Turkic identity has always been defined more by culture, language, and political organization than by genetics. One final misconception revolves around the idea that modern Turkish genetics were shaped only by conquests and war. While military campaigns certainly played a role in shaping Anatolia's history, trade, migration, and peaceful cultural exchange were just as influential in determining genetic patterns. Merchants, craftsmen, scholars, and settlers moved across the region for centuries, carrying their genetic legacy with them. This gradual and continuous mixing, rather than sudden invasions, is what truly shaped the modern Turkish genome. Ultimately, the scientific evidence paints a very different picture from the myths. Modern Turks are not simply Central Asians, nor are they purely European or Middle Eastern. They are the descendants of thousands of years of migrations, interactions, and adaptations, an intricate genetic tapestry woven from the remnants of Hittites, Phrygians, Greeks, Persians, Romans, Armenians, and Turkic nomads. The truth is far more fascinating than any political narrative, and it proves that history isn't just something written in books, it's encoded in the very DNA of the people. Despite its deep and ancient roots, Turkish DNA is anything but uniform. Across the country, genetic variations reveal striking differences between regions, shaped by centuries of migration, conquest, and local adaptation. From the shores of the Aegean to the rugged mountains of the East, each part of Turkey carries a unique genetic fingerprint. But what makes these regions so distinct? And how did their diversity come to exist? In Western Turkey, particularly along the Aegean coast, genetic studies reveal a strong affinity with Balkan and Mediterranean populations. This is no surprise. Greek colonization, Roman rule, and later Ottoman-era migrations all contributed to this genetic makeup. Even after the population exchanges of the early 20th century, the traces of centuries-old intermingling remain in the DNA of modern Turks from Izmir, Aydin, and Çanakkale, connecting them closely to Greeks, Italians, and Southern Europeans. Moving towards Central Anatolia, the genetic picture changes. Here, the influence of ancient Hittite and Phrygian civilizations is more pronounced. This region remained relatively insulated compared to the coastal areas, allowing older genetic lineages to persist. Modern genetic studies show that people from Konya, Kayseri, and Ankara carry higher percentages of Neolithic Anatolian and Bronze Age steppe ancestry, reflecting the deep historical continuity of the region. In eastern Turkey, the genetic profile shifts again, this time toward Caucasus and Iranian influences. Cities like Van, Erzurum, and Diyarbakir show stronger genetic ties to Armenians, Kurds, and Persians, reflecting centuries of interaction between these populations. The high frequency of haplogroup A2, commonly found in the Caucasus and Mesopotamia, supports this connection. Unlike the West, where Ottoman and Mediterranean influences are dominant, Eastern Anatolia retains a stronger imprint from Urartians, Assyrians, and other ancient Eastern civilizations. Along the Black Sea coast, yet another genetic pattern emerges. The people of Trabzon, Rize, and Giresun have distinct connections to Circassians, Georgians, and even some Slavic groups. This reflects centuries of trade and migration between the Pontic region and the Caucasus. Some communities, like the Laz people, have preserved unique genetic markers that set them apart from other Turkish populations, proving that regional identities in Turkey are not just cultural but also deeply rooted in DNA. Perhaps the most unexpected genetic variation comes from southern Turkey, where cities like Antalya, Mersin, and Hatay show traces of Arab, Levantine, and even North African ancestry. This reflects the centuries-old trade routes that connected Anatolia with the Middle East and the Mediterranean world. The presence of haplogroup EM78, common in North Africa and the Levant, indicates that migrations from these regions left a subtle but lasting imprint on the local population. Despite these regional differences, one thing remains clear. Turkey's genetic landscape is a mosaic, not a monolith. While different parts of the country carry distinct ancestral influences, they all blend together to form the unique identity of modern Turks. This diversity is not just a relic of the past. It continues to shape Turkey today, proving that the country's history is written not only in books and monuments, but also in the very genes of its people. For centuries, history has been written by those in power, shaping how people perceive their past. But genetic science has revealed a truth that often contradicts political narratives. The story of Turkish ancestry is no exception. Debates over identity, origins, and historical connections have been influenced by ideology as much as by evidence. But what happens when DNA tells a different story than what people have been taught to believe? One of the most controversial topics in Turkish genetics is the connection to Central Asia. While Turkish identity is strongly linked to the Turkic migrations, genetic studies have consistently shown that the vast majority of modern Turks descend from Anatolia's ancient populations, with only a small percentage of Central Asian ancestry. Despite this, some nationalist perspectives continue to emphasize the idea of a pure Turkic origin. The reality is far more complex. Turkish identity is a product of cultural assimilation, not complete genetic replacement. Similarly, political tensions have fueled misconceptions about genetic similarities between Turks and their historical neighbors. For example, some groups promote the idea that Turks and Armenians, or Turks and Greeks, are entirely separate peoples with no shared ancestry. Yet scientific research contradicts this, showing that Turks share significant genetic overlap with both populations due to thousands of years of coexistence and intermarriage. The genes do not recognize modern borders. Political divisions may exist today, but DNA reveals an intertwined history. Another source of debate is the extent of Ottoman-era genetic influence. While Ottoman rule spanned much of the Balkans, the Middle East, and North Africa, some claim that modern Turks have inherited large amounts of ancestry from these regions. However, genetic evidence suggests that while there was some intermixing, the overall impact on the Turkish gene pool was not as dramatic as often assumed. The strongest genetic ties remain to Anatolia's indigenous populations, rather than to more recent Ottoman-era migrations. Even within Turkey, regional identity and genetics can be politically sensitive. Some groups emphasize their distinct genetic heritage to claim unique origins, while others downplay differences to promote national unity. However, science shows that Turkey is neither genetically homogeneous nor strictly divided. The truth lies in between. Each region carries its own historical influences, but all are part of the broader Anatolian genetic legacy. Perhaps the biggest challenge in discussing genetics and identity is that many people want a simple answer to a complex history. But DNA does not provide a single, clear-cut origin. It tells a story of continuous migration, adaptation, and blending. The genetic evidence does not diminish anyone's identity. Instead, it enriches the understanding of what it truly means to be Turkish. The history of the Turkish people is not just written in ancient texts or carved into the ruins of past civilizations. It is encoded in their DNA. But even after centuries of research, new genetic discoveries continue to reshape our understanding of where the Turkish people came from and how they became the diverse population they are today. What have the most recent studies revealed, and what mysteries still remain unsolved? One of the most groundbreaking revelations in recent years comes from ancient DNA analysis, which has allowed scientists to extract and study genetic material from thousands of years ago. These studies have confirmed that the genetic continuity in Anatolia is far stronger than previously believed. DNA samples from Neolithic farming sites, Hittite settlements, and Byzantine-era burials all show a clear genetic link to modern Turks, proving that despite cultural and political shifts, the core population of Anatolia has remained largely the same for millennia. Another major breakthrough involves the genetic timing of migrations. Using advanced computational models, researchers have traced when certain genetic influences entered Anatolia. For example, the arrival of Indo-European steppe ancestry in the Bronze Age can now be pinpointed to around 2000 BCE, while the Turkic genetic contribution has been confirmed as entering the gene pool primarily after the 11th century CE. This level of precision has allowed historians to match genetic shifts with specific historical events, deepening our understanding of how migrations shaped the population over time. Recent genome-wide studies have also revealed fascinating insights into how different groups within Turkey are connected to one another. While previous research focused on broad regional differences, new studies have examined micropopulations, isolated communities that have retained unique genetic markers for centuries. In places like the Black Sea region, eastern Anatolia, and certain mountainous villages in central Turkey, small pockets of people have been found to carry rare genetic lineages that are distinct from the rest of the population. These groups act as time capsules, preserving genetic traces of long-lost civilizations that once inhabited these areas. Another area of growing research is the study of adaptive genetic traits in Turkish populations. Certain genetic markers related to diet, immunity, and climate adaptation have been identified, showing how the people of Anatolia evolved in response to their environment. For example, genes associated with lactose tolerance have been found at higher frequencies in regions historically dependent on dairy farming, while immune system adaptations linked to past pandemics suggest that Anatolian populations were shaped by diseases as much as by migrations and wars. Despite these advances, many questions remain unanswered. The full impact of pre-Neolithic hunter-gatherers on Turkish genetics is still being explored, as very few ancient DNA samples from this period have been found. Additionally, the role of maritime migrations, such as ancient movements from the eastern Mediterranean and North Africa, remains an open question, with some studies suggesting a greater genetic impact than previously assumed. Ultimately, genetics is proving what history has always hinted at. Turkey has never been a land of a single people or a single origin. Instead, it is a place where countless cultures, civilizations, and lineages have converged, blended, and evolved over thousands of years. And with each new discovery, the story of the Turkish people continues to be rewritten, revealing a past that is far richer and more interconnected than ever imagined.